If the questions on this video seem quite challenging, that's because they're meant to be. These are the grade 8 and 9 questions about equilibria. So on each slide, I'm going to pause at the beginning to give you a chance to stop the video and have a go yourself, and then you can resume the video and see how you got on. Question 1 says, look at the following reaction which is carried out in a closed system. And it's the reaction between ethene and steam to make ethanol. And we can see from the symbol in the middle that it's a reversible reaction. So what is meant by a closed system? Well, a closed system is one where the reactants and products cannot enter or leave the system. So imagine you've got a flask and you've sealed the top up, so any gases that are made can't escape, and likewise you can't start adding any more reactants halfway through the reaction. And what can we say about the rate of the forward and reverse reaction at equilibrium? Well, the forward and reverse reaction rates are equal. So that means that the forward reaction is going just as quick as the reverse reaction. And what is meant by dynamic equilibrium? Well, although the overall amount of product stays the same, so it might look like no new product is being made, new products are still being made, but at the same time they're being changed back into the reactants. In this question, the forwards reaction is exothermic. What would be the effect on the yield of ethanol, in other words, how much ethanol is made, by increasing the temperature? So first of all, we need to think about Le Chatelier's principle. And Le Chatelier's principle states that whatever change you put on that reaction, the equilibrium shifts to try and undo the change. So if you make the temperature lower, it will shift to try and make the temperature higher again. If you make the pressure higher, it will shift to try and bring the pressure back down again. So in this case then, we've labelled the equation to say that the forwards reaction is exothermic and the reverse reaction is endothermic. So according to Le Chatelier's principle, it will encourage the reverse reaction as that's the endothermic one. And remember, endothermic reactions tend to cool things down. So if we've increased the temperature, it will favour the endothermic reaction, which is the reverse reaction. That means the equilibrium will shift to the left, and that means there will be a lower yield of ethanol. And use this as a bit of a framework for answering these questions. So first of all, you say whether it will encourage the forwards or reverse reaction. Then you say if the equilibrium will shift to the left or right. And then you say if more or less of the product would be made. Sticking with the same reaction, what would be the effect on the yield of ethanol by increasing the pressure? And it's a good idea to draw the number of molecules on each side of the equation. So there's 2 molecules on the left, 1 molecule of ethene and 1 molecule of steam, and there's only 1 molecule of ethanol on the right. So according to Le Chatelier's principle, if we've increased the pressure, it's going to go to the side that reduces the pressure again, where there's less molecules. So it will encourage the forward reaction as there are less molecules on the right hand side. This means the equilibrium will shift to the right, and that means there will be a higher yield of ethanol. More ethanol will be made. This time we've got a different reaction. This is a good example of a decomposition reaction because we've got ammonium chloride breaking down to make ammonia, which is NH3, and also hydrogen chloride. And the question is, the following reaction is carried out in a closed system. Explain why a white solid is seen to form as the mixture is cooled. So all we're really going to do is talk about the changes that will happen as we decrease the temperature. So according to Le Chatelier's principle, reducing the temperature will encourage the reverse reaction as that's the exothermic reaction, and we know that exothermic reactions warm things up. That means the equilibrium will shift to the left, so more ammonium chloride will be produced, which is a solid, and we can tell that's a solid because it's shown by the state symbol, the little s in brackets after it. The reaction this time is the reaction between nitrogen and hydrogen to form ammonia, and anyone studying separate science will recognise this as the Haber process. So the question says, what would be the effect on the equilibrium position of reducing the temperature? And the forwards reaction is exothermic. So let's label that first of all on the equation. If the forward reaction is exothermic, the reverse reaction must be endothermic. So according to Le Chatelier's principle, it will encourage the forwards reaction as that is exothermic. If we reduce the temperature, it's going to try and increase it back again by encouraging the forwards reaction. So that means the equilibrium will shift to the right. How would this decrease in temperature affect the rate of reaction, and explain why? Well, there would be a lower rate of reaction as the reactant particles would have less energy, so there'd be less frequent collisions and also less successful collisions. Very occasionally I see this question on exam papers, and the last time it came up, even the people who ended up getting grade 9s, many of those didn't get this one right. So here's the equation. We can see it's a reversible reaction, and the question is, what would be the effect of increasing pressure on the yield of Cl2? So first of all, we draw the number of molecules on each side. We've got 2 HCl, so that's 2 molecules of HCl on the left, and we've got 2 molecules on the right because we've got a hydrogen molecule and a chlorine molecule. So in this case, there would be no change as there are equal numbers of molecules on each side of the arrow. And how would using a catalyst affect the equilibrium position? Well, there's no change as the catalyst speeds up both the forwards and reverse reaction. And that is true for all reversible reactions. The catalyst doesn't change the position of the equilibrium. If you found the video useful, please remember to give it a like and don't forget to subscribe so you don't miss out on future videos. Thanks for watching.